Hi, this is Rick. We're back into arrays, one of my favorite subjects. Don't forget that you should probably be watching this video after you've watched the other three. As we get into this, remember you can follow along with the book because the book has got all the information you need in it. This is just kind of an overview and kind of my opinion on things. Last time we got together, we looked at these three subjects. And now we're going to take a look at parallel arrays, two-dimensional arrays, and arrays of 3 or more dimensions. Oh my gosh, this is getting to be Star Wars. Yep, right there. Remember what an array is? It's a parking lot of variables. So a variable is a physical location in memory, and an array is a number of physical locations in memory that are contiguous, that means together, and they have the same data type. And you can put them in order, so you can go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't forget our numbering system starts with 0 when we work with arrays. It actually starts with 0 all the time, but we just don't think about it. All right, so here's some of our basics that we wanted to look at. When we work with arrays, it's normally going to follow a 4-step process. The first step is you're going to create the array. You're going to create the parking lot for all the variables in there. Then next thing you're going to do is usually fill the array with a loop. So you're going to step right through 0, 1, 2, 3, 4. All right, so the idea here is that we're going to take the subscript, which is a number, and we're going to use that as the index of our loop, and it's just going to walk right on down that entire array. So the sentinel value means the array size, and I for index, which is going to be equal to the subscript. Next thing you're going to do is process whatever is in the array. The last thing we're going to do is display the array contents with a loop. We're going to walk right on down, starting with 0 and going to 9 in our illustration, or you can go from 9 to 0 depending on how you want it displayed. So there's our 4-part stepwise outline. Sometimes, however, we don't have the array completely filled. So let's say that in this particular case, we start off with size equal to 100, and we're going to declare an array called values, which is size big, when size in this case is 100. So let's say that we're just going to put in a number of pieces of data, and we're not sure how many of the entire array we're going to actually use. So we're going to say enter a number or -1 to quit. We're going to input a number, and then it says while number is not equal to -1. Okay, so we qualified. And count less than size, less than 100. We're going to set values array position count equal to the number that we entered. Then we're going to say count equals count plus 1. Then we're going to display enter a number or -1 to quit and input a number. The idea here is that we're going to completely go through, we've got the opportunity to go completely through the entire array if we want to. Or we can stop by putting in -1. So let's say we only enter 5. We can go ahead and quit after we've entered 5 by putting in -1 and pressing enter. How do we go through an array and look for things? A sequential search algorithm is a simple technique for finding an item in a string or a numeric array. So basically what it does is it uses the loop to sequentially step through the array and look at every single element. It compares that element with a value being searched for. It stops when the value is found or the end of the array is hit. So here's an example. So we're going to set found equal to false. Now that's called a flag. And we're going to set index equal to 0. We're going to say while found. Now remember those double equals? That means it's a test. So we're checking for identity. So while found is false and index is less than or equal to size -1. We haven't said what size is yet. But whatever it is, it's -1 because we start with 0 in our array. So if the array position index is identical to the search value, then we set found equal to true. That's our flag. We also have the option of the fact that it didn't match. Else, we set the index to index plus 1. In other words, we use a counter. We end the if, and we end the while. So it's going to go back to the top where the while is, and again run that loop. How do we process the contents of an array? Well, we can total the value of an array and calculate an average. It's very simple to do, and it's very common to do as well. Loops are used to accumulate values, and you can see that we would just go ahead and add at the same time. So if you'll take a look at figure 6 on page 309, you will see that being done. How about if we find the highest and lowest value in an array? Very common. So what we're going to do is take a look at how to find the highest in detail, and then the lowest is just changing a sign. So when we were looking for the highest in an array, we create a variable to hold the highest value. Then we say the variable called the highest is going to be equal to whatever's in position 0. Then we use the loop to go through every single element of the array, and each time it hits another element of the array, we compare it to see if it's higher than the value we've got stored in our highest value variable, which is not in the array. It's a separate part. If the element is greater than the highest value, then that value goes into the highest value variable. Otherwise, it just passes by. If we wanted to do the lowest, it's the same thing, but in this case, it would check to see if the element was less than the lowest value we had stored in that separate variable called lowest value. Turn to Figure 7 on page 312 and study how that's done there. Turn to page 341 and do programming exercise number 4. Now, I will tell you that attached to this Blackboard entry is the answer to programming exercise number 4. If you want to take a look at it and come up with a strategy and then print out the answer, then you can compare yours to theirs, and you can also use it to figure how things are done in the highest, lowest, average printout. Parallel arrays are really cool. What we do then is we create 2 arrays. In this case, we have the names array and we have the addresses array. Notice they're both plural. And how do we know that person 1 actually owns the element in the names array 0 and the addresses array 0? Well, the only thing in common is the 0. What we do is we link them by subscript. Person 1 would have all their information in position 0 or subscript 0 of each one of these several arrays that we had. Here's another example. Here are 2 arrays. They're parallel arrays because the information is actually linked by the subscript. So I'm going to represent this in a different way, and hopefully it'll make it a little bit clearer. I'm going to represent this as the valid item array, 6 elements big, and I'm going to do it vertically. So we've got valid items, and we've got valid prices that go along with those items. So the valid price is also an array that's 6 elements big. So what's on the left is the item number. So if someone goes in and types item number 106, we then want it to go get the price for that particular item, and we're going to do that with a parallel array system. Don't forget we're numbered from 0 to 5. That's how many a 6 element array really has as labels. So we have subscript 0, subscript 1, position 0, position 1, etc., whatever you want to call it. And so does the other valid array. So at that point, we've got different data in each array, and by the way, they can be different data types as well. But we're going to represent our valid items as numbers inside the valid item array position with 6 elements in it. And then we're going to represent the prices of those items by the parallel array subscript. So item 106 actually sells for 59 cents. And they're linked by the subscript. So we would say valid item array, subscript 0, and valid item price, or valid price, subscript 0, are linked together. We can also have a 2-dimensional array. Here's a 2-dimensional array that represents the columns and rows of students and the exams that they take. So let's just kind of take a look at this. You'll notice that, oh, by the way, when I was a kid, we had a thing called RC Cola. And that's how I remember what comes first. So I'm going to actually number the rows first. So I'm going to say row 0, position 2 would be this particular element. And row 2, position or element 3 would be this particular element. So at that point, you always start with the rows and then go to the columns. If we look at a 2-dimensional array, it's something that you have to declare. So you say, in this particular case, an integer called rows is going to be 3, and an integer called cols is going to be 4. And then we're going to say declare integer values, rows, columns. So at that point, we're actually going to use 2 loops. So for row equals 0 to rows variable minus 1. So remember, we start with 0, so that's the reason we've got that minus 1 in there, so we don't have that off by 1 error. So this is for those rows, and for those columns, and here we go, we're going to say for col equals 0 to cols minus 1, so that's going to go from 0, 1, 2, 3. That's the number of cols we've got. And we're going to display, enter a number. We're going to input the values into the row position, or the row element, by column element. And then we're going to end the first for statement, that's for the columns, and then we'll end the second for statement, that's for the rows. And so we're going to walk right on through. So we're going to say, for the first row, we're going to go 0, 1, 2, 3, and then we're going to go to the next row, and we're going to go column 0, 1, 2, 3, and then we're going to go to the next row, and we're going to say column 0, 1, 2, 3. Well, on that same vein, we can have a multi-dimensional array. So in this particular case, we're going to have more than one dimension, and we're going to declare a real array named seats. And you notice we got that same thing, RC, rows and columns, but now we've added pages. So we locate the row, we locate the column, and then we locate the in-depth page. So if we were to look at row 1, column 1, page 0, it'd be right there. Okay? Can you tell what this one is? That's on the second page. So it'd be row 2, column 3, page 1. All right? How about this one? That's going to be row 0, column 3, page 2. Okay, turn to the review questions and do 7 through 10.